Please
Yes,
take it
hi.
away.
Hopefully you can hear me. I'm Kirby Runyon at Johns Hopkins APL, and I'm an early career staff planetary geologist here. And I'm really excited to talk to you about the kickoff of our newly funded NASA Solar System Workings project. So thanks to NASA's SSW program for selecting this. That was just funded. And that is to using parabolic flight experiments to understand crater ejecta emplacement on small bodies. Now, of course, ejecta emplacement is ubiquitous across the solar system, and it's a major agent of geomorphic change. This image here of Pluto's moon Nix shows a beautiful ejecta facies around this large crater here. And if we really understood the ejecta emplacement dynamics at the detail level, we could kind of run the clock backwards, if you will, and kind of put that ejecta back at the stratigraphic layer in the crater from whence it came. And we can also start to understand some of the subsurface regolith processes that occur as ejecta gets in place on top of it. So understanding the granular dynamics and morphology will aid geologic interpretation of remote sensing and also return samples. And so what we're planning to do is to use an ejecta catapult on parabolic flights to launch granular media onto granular beds, analyzing the dynamics and the resulting morphology from slow motion video. This builds on several years of research, including some projects I did for my PhD, where here at Johns Hopkins APL, we have a 1G, roughly meter-sized catapult that creates an ejecta curtain composed of pea gravel that we've shown is dynamically similar and scales for natural ejecta curtains. And what we would do is we would subscale that, kind of shown in some of the middle images there, to something we can take on a parabolic flight aircraft and look at granular ejecta dynamics. We'll start with lunar gravity, and we can go down to kind of centigravity, milligravity conditions that the aircraft is ideal for showing. Some of the things we've shown in the 1G catapult in the lab is that we get a significant amount of subsurface shear in the regolith as ejecta gets placed on top of that. We're going to be doing these experiments on G-Force 1, run by the Zero Gravity Corporation. Our first flight is scheduled for this coming November. They are flying during the pandemic, fortunately, and we're currently building our experimental apparatus. We're excited that these results could be very applicable to large small bodies, such as the asteroid Psyche, that has gravitational accelerations in the few centimeters per second squared. So that's my spiel. Thanks for listening.